So we're going to begin talking about dilations. A dilation is just an enlargement. On a smartphone, you're used to dilating pictures all the time. When you pinch zoom, you're dilating that image. You're zooming in on it, you're looking at it closer, it's dilating it. Now usually on the smartphone, you're only looking at a small portion of it that you zoomed in on or whatever, but that's all a dilation is, except you look at the entire thing. So if the image stays there, but you see the whole thing, that's a dilation. When you do that, the image isn't changing, it's just getting larger. So the size changes, but the orientation doesn't change. The overall shape of it does not change. If it's a rectangle, it's going to be a rectangle. If it's a square and you dilate it, it's still a square. If it's your face and you dilate it, it's still your face. It doesn't change. So, like I said, a dilation is a transformation that can change the size, but leaves the shape unchanged. So size changes, shape does not change. So this is the only transformation that changes the size. Everything else we've done has all been the same size. That doesn't change. Translations, reflections, rotations, those do not change size. Dilation is the only one. So when the size changes, that's called the scale factor. If you were to zoom in on your picture on your phone, 200%, that's got a scale factor of 2 because you doubled it. You went from 100% to 200%. That's called the scale factor. You can also have a smaller scale factor, like a fraction, like a 1/2. That'll be zooming out so that you see like 50% of it. That would be a 1/2 scale factor. So there is a center of dilation, which, sticking with the pinch zoom in, it's the part where you pinch zoom on. If you pinch at a certain point, that's the center of dilation. That's the part that gets larger. That's where everything's focused about where it gets larger. So it's a fixed point where all the other points are transformed by the dilation. Ratios will be ratio of the lengths of corresponding sides in the image and pre-image. That's called the scale factor. So when you look at the ratio of the sides, if it doubled in size, you have a scale factor 2. If it's half the size, you have a scale factor 1/2. So preserves angle measurement. Angles won't change because the shape isn't changing. So angles don't change. Betweenness, it's a weird word, but it just means like if something is between two other parts of the picture, that's going to stay that way. Collinearity, if it's a straight line, it's a straight line. Orientation also stays the same. Talking about the scale factor again, it's the ratio of the side lengths. And if you're dilating just lines, those lines will, if it's not the same line, it will be parallel lines. So we're going to basically go through these like a checklist to see if the transformation is a dilation. Now, for this, you can probably tell just by looking at it, it's a reflection. We're pretty good at identifying those things by now. So, but we're going to go through it like a checklist. Does it preserve all the angle measures? So are all the angle measures the same? Is angle A prime the same as angle A? Does it preserve betweenness? So anything that's between A and D over here, is it still between A prime and D prime over there? Yeah. Are the things that are collinear, so straight lines, that stays the same? How about orientation? Since we're going A, B, C, D in a counterclockwise order here, would have to be the exact same on the A primes. Are we going A, B, C, D counterclockwise on the other side? No. If the letters are in a counterclockwise order, the letters need to remain in a counterclockwise order. Scale factor, so compare the side lengths. This has this side, or this side is 4, this side is 4. Bottom side's 4, bottom side's 4. So the scale factor, it doesn't change. The scale factor is 1. So is it a dilation? No, because orientation got messed up. Scale factor of 1 would be a boring dilation also. So here's another one. Does it look like all the angles are the same? You could, if you wanted to get precise, you could pull out a protractor and measure it. I'm just going to tell you, yes, they are. I measured them before. Does it preserve betweenness? Is everything that's between A and C still between A prime and C prime? And all the way around, yes. Collinearity, so are things that are collinear? A and C are collinear, A and C are collinear, yes. How about orientation? We're going A, B, C in a counterclockwise order. A prime, B prime, C prime, counterclockwise order, yes. Then to find the scale factor, you just compare side lengths. So AB, you can find the length of that, or any of the sides if you want. We'll do AB. So I would turn this into a right triangle. It's 1 and 3 for the sides of that right triangle. So Pythagorean theorem, 1 squared plus 3 squared. That's 9 plus 1 is 10. So we'll do the same thing for A prime to B prime. This has a side length of 2 and 6. 2 squared plus 6 squared. That's 36 plus 4 is 40. Square root of 40. Which you can simplify using your old algebra skills. 40 is 4 times 10. 4 is 2 times 2, so we got a pair of 2's that get to come out. And we'll just keep the 10 inside because there's no pairs within 10. So 2 square root of 10 compared to regular square root of 10. How much larger is 2 square root of 10 when it compared to 1 square root of 10? It's twice as large, so the scale factor is 2. It was just multiplied by a 2. So all the answers are yes. It has a scale factor, so is it a dilation? Yes. So same checklist, preserves angle measures, yes. Betweenness, yes. Orientation, it's going around counterclockwise, A, B, C, D, E, A, B, C, D, E. Collinearity, just like betweenness, yes. For the scale factor, you put the image over the pre-image. So pick a side that's easy to calculate, like either DE, because it's flat, or CD, because it's vertical. You can count it for the length. So let's go DE. This has a length of 3. And then D prime, E prime has a length of, it's kind of hard to count because it's a half right there, it looks like. 1, 2, 3, 4 and a half. If you don't like the half, then you pick a different side. This side has a length of 2, and this one's got a length of 3. You pick the image over the pre-image. So the primes over the regular. So 3 over 2. That's our ratio, that's our scale factor. 3 over 2 or 1.5, however you want to write it, doesn't matter. But you do the image over the pre-image to get scale factor. go back and write that down. Image and pre-image, if you do image over pre-image. So is it a dilation? Every answer was yes, it's got a scale factor, so yes, it's a dilation. Does it preserve angle measures? This one's actually no. If you were to measure these angles, this angle down here at C prime is larger than the angle at C. Does it preserve betweenness? Yes. Things that are between are still between. Collinearity? Yes. Orientation? No. ABC going counterclockwise, now it's ABC going clockwise. Scale factor doesn't really have one because this side is different than the other side, so it doesn't have the same scale factor. So depending on which sides you pick, you're going to get a different scale factor. If you pick AB to AB, you get a scale factor 1 because the side lengths don't change. But if you do BC to B prime C prime, you get a scale factor of 3 to 4, which is different. So it doesn't have a scale factor because it is not a dilation. You knew that right away because angle measures were different and orientation was different. This is like a reflection that they messed up on.